Okay, so this is 8.3 part 2, and I stopped off in these examples where we're using substitution. So once again, we have to solve the equation. We have tangent inside parentheses. We have theta minus pi over 2 equals 1. I can't solve this as it stands because it's not just tangent theta. It's tangent theta minus pi over 2. So this is why we have to use substitution. So whenever you use substitution, you're going to have to use either 2 pi k for sine and cosine, or pi k for tangent and cotangent. And in this case, we're using tangent, so we're going to have to use pi k. So the first step is to use substitution. So I'm going to say that I'm going to let x equal theta minus pi over 2. And the reason why I'm using substitution is because I can't solve that without using substitution. So if I plug in x for theta minus pi over 2 into the original equation, I get tangent x equals 1. So I know that tangent is positive in quadrants 1 and 3, and tangent 1 equals 1 at 45 degrees. So that's my first one. So x equals 45 degrees, or pi over 4. And in quadrant 3, x is going to equal 225 degrees, or 5 pi over 4. And once again, I got these values off the unit circle, or you might have them memorized, or you can use the triangles and just move those values into the appropriate quadrants. Okay, so I have these two answers, but remember, it's in x. So x equals pi over 4, and x equals 5 pi over 4. So my second step is to find a formula. And I'm looking for a formula so that way I can get my answers. So I'm going to resubstitute. Remember we said that x equaled theta minus pi over 2. With that being said, I have x equals pi over 4. So now I can rewrite that as theta minus pi over 2 equals pi over 4. Now remember, I'm trying to find a formula, so I'm going to tack on pi k. So now I have to get theta by itself. So theta equals pi over 4 plus pi over 2 plus pi k. So I have to find a common denominator. So pi over 4 equals 2 pi over 8. And pi over 2 equals 4 pi over 8. And then we have plus pi k. So theta equals 6 pi over 8 plus pi k. And by the way, I had to find a common denominator because I couldn't add pi over 4 plus pi over 2. My dog is acting crazy right now. I'm trying not to laugh, but it's pretty crazy in my house. So 6 pi over 8 reduces down to 3 pi over 4. And I'm just going to make sure I did that right. So 2 goes into 6 3 times, and 2 goes into 8 4 times. And then we have plus pi k. So let's write that out. This is going to be formula number 1. Theta equals 3 pi over 4 plus pi k. Okay, I have to find formula number 2. And I'm going to highlight formula number 1 just so we don't lose it over there. So once again, remember we said that x equals 5 pi over 4. So if x equals theta minus pi over 2, I can plug that in. So theta minus pi over 2 equals pi over 5 pi over 4 plus pi k. So I'm going to move the pi over 2 over to the other side. So I'm going to add it. And I'm going to have to find a common denominator. So lucky for us, we already did the common denominator part. So this becomes 10 pi over 8 plus 4 pi over 8 plus pi k. Theta equals 14 pi over 8 plus pi k. And then I have to reduce it down. So if I reduce this down by 2, I get 7 pi over 4 plus pi k. So here's my second formula, and I'm going to go ahead and highlight it. Now, I need more space because as you see, these take a while. So what I'm going to do is I'm going to erase that first part, which was use substitution. And I'm going to work on step number 3. So step number 3 is to use the formula to find the answers. Okay, so I'm going to use formula number 1 first. And formula number 1 was theta equals 3 pi over 4 plus pi k. Now before I do that, if I look back up, I do have a stipulation. So let's deal with that stipulation first. I notice that I have a 4 as a denominator in both formulas, formula 1 and formula 2. So if I rewrite the stipulation, I'm going to have 0 is less than or equal to theta, which is less than or equal to 8 pi over 4, because that's what 2 pi becomes if I use a common denominator. So I'm going to keep this stipulation up here. That'll let me know when to stop. So if I look at formula 1, I'm going to let k equal 0 first. So theta equals 3 pi over 4 plus pi times 0. So theta equals 3 pi over 4. So here's one of my answers. And that's an okay answer because it does not exceed 8 pi over 4. So now I'm going to do the second one, k equals 1. So theta equals 3 pi over 4 plus pi times 1. Now I know that this is going to be too big. And the reason why I know this is too big is because actually it's okay. I don't know what I'm talking about. But pi equals 4 pi over 4. This equals 7 pi over 4, which is an okay answer. That does not exceed 8 pi over 4. K equals 2 will give me trouble because we have 3 pi over 4 plus 2 pi. Now I know this is going to exceed it because my stipulation ends at 2 pi. But if you don't see that and keep on adding it, 8 pi over 4 is equivalent to 2 pi. This is going to be 11 pi over 4, too big. Okay? So far I have 2 answers. Let's use formula number 2. So theta for formula number 2 equals 7 pi over 4 plus pi k. So k equals 0. Theta is going to equal just 7 pi over 4 because that pi times 0 will drop off. By the way, I already have the answer, but I'm going to circle it anyways. K equals 1. Plugging that in, we get 7 pi over 4 plus pi times 1. Finding a common denominator, it's going to be 4 pi over 4. When I add 7 pi over 4 plus 4 pi over 4, I get 11 pi over 4, which is too big. So I don't move any further. So my answers, so let's get some space. I'm going to have 2 answers. I'm going to write them up. So I'm going to use the curly brackets. To write this up, the smaller one is 3 pi over 4. And then I have 7 pi over 4 as the next value. By the way, I'm not going to write 7 pi over 4 twice because it's redundant. So this is my answer for this question. So before I do objective 2, let's just run over when do we use 2 pi k and when don't we use it. So you're going to use 2 pi k for sine or cosine. Okay? you're going to use it when you have to come up with a general formula. And this is when theta is by itself, but it does not have a stipulation. Or if you have to use substitution. And then you have to find a formula. You have to use 2 pi k for that. You're going to use pi k for tangent and cotangent. Okay, so just a little note there. And once again, you're going to use it when you have to use substitution or when you have to come up with a general formula. You do not use 2 pi k when there's a stipulation and you're not using substitution. That's the only time you don't use 2 pi k. Alright, so hopefully that makes sense to you. If not, rewatch the videos. I highly recommend that. The last video is going to cover objective 2, which is solving an equation quadratic in form.